so if we look at this word equation, it's going to be barium chloride. We don't want to put the di in because that would be for covalent compounds. One thing, I'm not sure if I mentioned to put this in there, but aqueous, do you remember what aqueous means? It's dissolved, right? So barium chloride dissolved in water is combined with, and that's a little wordy to say dissolved in water. So I could also say a solution of. So I could say barium chloride solution is combined with sodium. What ion is that? CrO4 is chromate. So combined with chromate, sodium chromate solution yields, and then my other two compounds, you just switch the names basically, and you've got solid barium chromate, or we could say a precipitate of barium chromate, and like you said, table salt, salt water. We could say aqueous sodium chloride. So I said the AQ in three different ways. I could say barium chloride dissolved in water, I could say solution of barium chloride, or I could say aqueous barium chloride. But did you guys essentially have that for the excuse me, for the compounds? So one thing I want to make sure we know is that when I have those coefficients in front of the balanced equation, those are relating molecules to each other. We can also say they're relating moles to one another. So like 1 mole of H2 and 1 mole of Cl2 gives me 2 moles of HCl. I can also technically say 5 moles of H2 plus 5 moles of Cl2 would give me 10 moles of HCl. That works too, but really I want my equation to represent the smallest whole number ratio between those three. What it doesn't represent is mass. If I look at this picture here, again, 1 molecule to 1 molecule gives me 2 molecules, 1 to 1 to 2. But with grams, we can convert moles to grams just like we did before. But it's going to be a totally different number for moles to grams. So 1 mole of H2 is 2.02 grams if we divide it by the molar mass. I'm sorry, multiply it by the molar mass. So what we're saying is, even though it's 1 mole, 2 moles, the mass ratio is 2 grams of hydrogen to 71 grams of chlorine. Gives me 73 grams of hydrochloric acid. So don't confuse that and think that the balanced equation is telling us grams, because it's really only good for molecules or moles. Those are going to be numerically the same. This was a reversible reaction. Notice the same ratio holds true if the equation is moving to the left versus if the equation is moving to the right. And a couple other things that the chemical equation doesn't tell us. It doesn't tell us if the reaction will actually occur. For instance, sodium is a very reactive metal. If I have sodium chloride and I mix it with something like gold, gold is very unreactive. It's not going to do anything. They're probably just going to, gold and salt, like if I got salt on my ring, it's just going to sit there. It's not going to do anything. So I could write out an equation that theoretically the gold replaces the sodium, but that doesn't actually work in reality. Chemical equations also don't tell me how fast the reaction happens. So like rust could happen very slowly over time from the moisture in the air, or it could happen very quickly if I soaked like a piece of iron in water, it might react a lot faster. It will react a lot faster to that water and go a lot faster, but the chemical equation itself doesn't tell me that. So step-by-step approach, just to kind of rehash everything we went over. First, try to identify the names and the reactants of the reactants and products using a word equation. And then you're going to substitute those words for formulas. Notice that equation is not balanced yet. That's our next step, is that we want to balance it. And just some tips and tricks for balancing equations. Again, do how we did. Go through the different atoms, balance it one at a time. First, try to balance the elements that are combined and appear only once. So what does that mean? If we look at the equation we did yesterday, we had CH4 and O2 yields CO2 and H2O. It's not going to be a good idea to look at oxygen first, because oxygen appears in multiple compounds. Really, we want to try to balance something else. Another reason oxygen isn't good is because it appears by itself. It's helpful if you try to balance things that are in another compound first. So things like carbon. And oxygen is actually going to have 3 strikes against it in this particular equation. Because another trick they give us is that we don't want to go for H and O first. They're usually the ones that give us problems. So try to balance everything else other than H and O if you can, and then save H and O. That's going to save you some headaches if you try to balance those things first. So we'll try a couple examples here. We've got zinc. The reaction of zinc with aqueous hydrochloric acid produces zinc chloride and hydrogen gas. So zinc is easy enough, right? What state of matter do you think zinc is going to be in, most likely? Unless we're working at thousands of degrees. I'm assuming it's going to be solid, right? Aqueous hydrochloric acid. Do we know how to write hydrochloric acid? Have we worked with it enough to know that it's HCl? I know I didn't require you to learn acids last chapter, but hydrochloric acid is a common one. It's HCl. So they gave us zinc. They said aqueous hydrochloric acid. Notice they're telling us a solution of zinc chloride and then hydrogen gas. All important parts to be aware of. So zinc chloride, zinc has a charge of, what's zinc's cation have a charge of? +2, good. And chlorine has -1. So what do you think my formula would look like for zinc chloride? Zinc's +2, chlorine's -1. You got it, ZnCl2. And it's a solution, so I'm going to use AQ. And then hydrogen gas. Is it just H? Is just H enough? Or is there something we talked about yesterday I need to add there? Yeah, but it's not combined with another ion. So we don't need to worry about that. That's what I would go for, is the H2. Because those, remember those 7 elements that are diatomic? We've got another one I heard was Dr. Hofbrinkel, HOFBRINCL. But I don't know, have no fear of ice cold bubble tea. Well, the tea, there's, maybe ice cold bubbles, because there is no tea element on there. But yeah, H, so that tells me that H has to be H2. Just a little refresher from yesterday. So H2 is in fact a gas. And now we need to balance it. This one actually is a lot simpler than the next one we're going to do. If we look through this, zinc is good on both sides. H is not good and Cl is not good. But what's one simple thing I can do to balance both sides? I can add a number. So I only have one hydrogen on this side, but I have two on this side. Yeah, if I just put a 2 here, that solves my hydrogen problem, because now I have 2 hydrogens. It also solves my chlorine problem, because I have 2 chlorines on both sides. So that one's relatively easy in terms of balancing. I want to look at a little bit more challenging one, and then we'll do some practice problems. This one, we don't see this much, so they had to give us the formula. Aluminum carbide, which is Al4C3, and it's solid, reacts with water, which I'm assuming will be liquid. We don't know if it's room temperature or not, but it's probably safe to assume. It's going to produce methane gas, which I think at this point they're starting to expect us to know. Common things like methane is CH4. And solid aluminum hydroxide. Anybody know the charge of either aluminum or hydroxide off the top of your head? You got it. So, and then hydroxide is -1. So it's going to be AlOH3. We good with that? And then it's solid. Any questions on how we set up the chemical equation? All right, so then I'll give you kind of the play-by-play over here. You do not have to write this out, but it can be helpful to see aluminum, carbon, hydrogen, and oxygen. Aluminum's got 4 on the left and 1 on the right. Carbon's got 3 on the left, 1 on the right. Hydrogen has 2 on the left. I'm careful because I missed this H4 last time I did this. There's actually 4 hydrogens here and 3 hydrogens here, so there's 7 on the right. And an oxygen's got 1 on the left, 3 on the right. So first thing, that's a lot of craziness going on there. Remember, try to save O's and H's for the end if you can. Start with your aluminums and carbons because they are in their own compound. I'm just going to go ahead and multiply aluminum by 4. That's just how I tend to work it out, is go left to right. So let's just multiply this thing by 4. Gives me 4 aluminums. It also affects oxygen. You guys see how many oxygens there would be on that side? You got 3 sets of oxygens times 4. It's actually 12, right? And then hydrogen, there's 4 plus 12. So we're going to get 16. Getting a little crazy here. Because now the carbon, I know I need to do something to carbon because this has to be more than 1. So I'll put a 3 there to match the one on the left. That's going to affect hydrogen more. It's going to bring me up to 12 plus 12. Now I have 24. So aluminums are good. Carbons are good. There's one last thing I can do to make hydrogens on the left match 24 and 12. Any idea what coefficient I want to put in front of water? 2 is only going to bring me up to 4 and 2. I need to go all the way up to have 24 hydrogens. So yeah, let's put 12. Is that what you said? Or did you? Gotcha. I just wanted to make sure I didn't mishear you there. But does that make sense now? Why is 12? It's 24 hydrogens and 12 oxygens. Good. So I just have 2 questions here that we will look at in a second. First one's with the law of conservation of mass. Talk about what we want to balance when or what we want to adjust when we're balancing equations, and figuring out which one is the correct chemical equation for that formula. And this is another important one, looking at what statements are true in terms of grams, moles, and molecules. And then finally we have a determine the products and write a balanced equation for the chemical reaction of solid magnesium and water. We have precipitation of iron 3 hydroxide is produced by reacting an aqueous solution of iron 3 chloride with an aqueous solution of sodium hydroxide. Write a balanced chemical equation. So if you want to try those,